Okay, so you guys know you're being recorded at the moment. Okay. All right. So.
Hey, did you get the new update on the iPhone where they can have black emojis?
Oh, did everyone see the new emoji? No.
I can't find it. Where are they?
Yeah, I heard about it. It's not my problem.
Yeah.
Wait. What?
Okay, look. I go to my emojis. Go to, are they in people?
Is your shit? Is your shit up?
Dude, that'd be really cool. Like, what if we were like the whole time?
Okay, guys.
Some emojis offer different.
Okay. Well, I wait to hear back from her.
I know.
I just made her.
Is she gonna supervise?
It's a Snapchat though. Should unfreeze my screen.
Snapchat? Where? Look. Snapchat.
Wait, what are the names?
Barbara.
Her
Yeah, what-
name is Professor. I don't know how to say it.
It's probably not nice.
Professor T. Okay. She's gonna have a doctoral student with her. So.
Where's it coming out of?
What?
Is she Skyping you or are you Skyping
Wait,
her?
are all your classes FaceTime one?
It's Skype.
Okay. All right. Ready?
FaceTime and Skype are different.
Yes.
Same concept, but yes. Okay. Here we go. You ready?
My boy is scary. It's her.
Okay. Hi.
Hello.
Okay. Can you hear us? Okay.
Yeah, we're good.
Okay. So these are my fourth hour students. Everybody say hi.
Hi. Hi,
Okay.
fourth hour.
This is Professor T, because I don't know how to pronounce your name.
Barbara.
Okay.
It's
So
Barbara.
there's- okay, so we have Barbara, and I'm sorry, who else?
Alex.
Alex. Okay. All right. So you guys, what I did the other day was that other document that we had started, where you write down all your questions, your other questions. I went through and picked out about 10 and sent to them. Can you still hear me? Okay.
Yeah.
Okay. All right. So I sent about 10 of those questions to them, so they could kind of prep and kind of get an idea of some of your thoughts and questions and things you were curious about. So they're going to answer some of those and maybe go off on some other things that are interesting to them. Okay? All right. So whenever you guys are ready, go for it.
Okay. You gonna start with one?
Sure. All right. So at least just going forward in the way you sent, the first question that was on there was, would there be waves in water without the moon? So a little bit of a semantics argument. So waves, yes. So any time there's a disturbance, so you throw a rock in some water, that'll make waves propagate. Now tides, on the other hand, which I think maybe was the idea behind the question, those would no longer exist. So high tide and low tide at the beach, those would cease to be.
So, yeah, waves. And if you go to a lake, there's no tides on a lake, but if there's a breeze, boy, we were out by Clinton Lake here on Sunday, really, really windy, big waves for a small lake. So anytime there's wind and weather, there's going to be some waves, but Alex said it right. There wouldn't be the kinds of tides that we see now if we didn't have the moon. We had some discussions this morning about some of your other questions. They seem to involve a lot of catastrophes. You guys have a lot to worry about. We should probably move some of these lower down on your list of things to worry about, like the Earth going out of orbit. We talked about what that would take a lot. back in the day when the solar system was just forming, this was a crazier place to be. A lot more things were hitting smaller planets, and that's how those smaller planets got to be bigger planets. But there isn't that much stuff floating around in the solar system anymore, and there's nothing that is big enough to move Earth out of its orbit. So that's one we should probably take off of your worry list.
Another question was about how much fuel it would take to get out of orbit. So I think the best way to think about it is how much stuff would you like to get out of orbit? Do you want to get you out, or a whole rocket ship, or a whole kind of like a space, the whole space station? Just depends on how much mass you want to move. If the quick mass ratio calculation would be for every 1 pound that you want to move out, you would need 40 pounds of fuel. So as you move more and more stuff, you need more and more fuel. So it takes quite a bit of fuel to get out of orbit.
So astronauts pack really, really light.
Yeah.
They don't take a lot of extra stuff with them.
But freeze riding, the astronaut food, if anyone's ever had astronaut ice cream or anything like that, it's all very, very light, and all the water's zapped out of it, so that way you don't have to take any more weight.
Dippin' Dots started out as astronaut
Did not.
Yeah, so if you think of Dippin' Dots compared to regular ice cream, how much, like regular ice cream, it's really wet. Okay, Dippin' Dots isn't so much. More it's lighter, it is more expensive. Okay.
Okay.
So, let's see. There was another question last night that I was going through, and it had to kind of do with when the further out we explore. So how do the Voyager, that's way far out there right now, how does it keep going? It can't pack enough fuel for that. So how does it keep going that way? And then it talked about some of the stuff that we had read was about changing paths to intersect with different planets. Well, how does it do that with very little fuel or no fuel on board? Mm-hmm. So that was one of the questions that I ran across last night. I have no idea. So.
Well, unlike you on a skateboard going down a sidewalk, if you have a skateboard and you're going down a sidewalk, you need to keep kicking yourself along because the skateboard slows down because of friction. There really isn't much friction in space. So once a spacecraft like Voyager is trucking along, and obviously it's been trucking for a long time, there isn't much to slow it down except just kind of gradually pulling away from the sun's gravity. When spacecraft carry fuel, they mostly are going to use that to fire little rockets on one side or another. So now think about yourself on your spaceboard with some little jetpacks. The little jetpack can fire out this way or this way. And if you fire your jetpack one way, you might turn the other way. So the rockets are used and the fuel is expended to change the course of the spacecraft. So they don't do that very often. They do that as little as possible. But the Voyager spacecraft will keep moving indefinitely. We may not keep talking and listening to them forever, but they're probably going to keep going for a really, really long time.
Yeah.
Got anything on that?
Well, this is probably dating me a little bit, but if anyone watched the movie with Tom Hanks, Apollo 13,
No, I have other movies.
okay, so you know that they go around the moon and use the moon's gravity to kind of slingshot them back to Earth, help change their direction. So that's another thing that we can use with spacecraft to save fuel is essentially throw them around objects to change directions. And then while they're there, it's great because then they can take data for us.
Yeah, and that reminds me to make a Pluto plug. I don't know if you'll get to study all of the planets and smaller planets in the solar system, but July 14th, a spacecraft will pass by Pluto and its moons. and this is the fastest spacecraft that ever left Earth, but it used just what Alex said. It was timed so that it could go by Jupiter and get a little boost in speed and keep going to way, way, way out there in the solar system and beyond. So mark that down on your calendar, July 14th, New Horizons at Pluto. How many of you saw any of the lunar eclipse last weekend?
I didn't.
It was too early.
It was too early.
They were on spring break.
Try.
I sympathize. I woke up not on purpose, but I'm awake. I'll look outside. You know, it's the lunar eclipse. It's cool.
Yeah, I tried.
I didn't even know there was.
Some of your questions were about how the moon reflects light, right? So all of what you've learned about the basis of the moon involves reflected sunlight. And a couple questions were like if the moon acts like a mirror, if it reflects or bounces light, could you see it from other places in the solar system? And the answer is yeah, absolutely. It's not very big, so it wouldn't be very bright, but sure. The sunlit side of the moon should be visible from great, great distances in the solar system. And a couple of you also asked about the kinds of light that the moon can reflect. The moon is actually really, really dark. It's about as dark as this black iPad cover. It doesn't reflect very much light, and it absorbs a lot. But it reflects white light, red light, probably ultraviolet light. And one of the things that astronomers have been doing for decades is shining a laser to the moon, and it gets reflected by little reflectors left by the astronauts on the Apollo missions, and we count how long it takes the light to go there and come back. And that's how we measure the distance to the moon all the time, very, very precisely. Not because we're not sure about it, but because we want to know how it's changing by little bits and what that means.
I heard that the moon is getting closer. Like its orbiting is changing to where it's getting drawn in by the Earth. Is that true?
It is actually moving farther.
Ah.
It is moving farther out, like inches per year, not that much, per century rather. And Earth is slowing down in its spin very, very gradually. And this is all part of this relationship we have with the moon and our oceans and that kind of stuff.
So would that tie into climate change, global warming? I mean, is all that stuff linked together, do you think?
I think it's too slow to compete with the other things that are driving climate change, which is mostly us.
Yeah.
It's way higher on my list of things to worry about.
Yeah, than the Earth falling out of orbit.
Right.
Yeah.
Or there was another one here that was, we're going to help you move way down.
Yeah, when the sun blows up, we have enough light and radiation to keep us alive. So I would say the first thing, when the sun blows up, we're not going to need to worry about anything. It's going to destroy us very quickly. When the sun goes red giant, where the Earth is currently would be inside of the sun. And it's very hot inside of the sun.
Yeah, that's not going to be a good situation.
Yeah.
But that's a long, long, long time in the future. That's thousands of millions of years. Thousands of millions of years. And humans have been walking around on the Earth for a couple million, being generous about what we call humans, probably.
Yeah.
So our time will have come and gone by then as a species. That's just the way nature goes.
If we still need Earth at that point,
Yeah.
hopefully we're somewhere else in the.
Hopefully people might be somewhere else.
Yeah.
Okay. So, go ahead.
So from some of the questions you said earlier, there were a couple questions about black holes.
Mhm.
Just some general black hole facts. So, how do we talk about a black hole, or what is a black hole? So you're on Earth and you're stuck here. You jump and you come back down. Without a lot of energy, you can't escape Earth's gravitation. So now imagine something that gets heavier and heavier and heavier. So heavy that no amount of fuel or energy will let you escape its gravitation. No matter how light you are, no matter how much energy you have, you just can't get away. That's what a black hole is. Light can't get away, nothing can get away. Once it's inside, it stays there forever. Well, basically.
So like,
And then someone else asked, what's inside a black hole? And so, I guess the truthful answer is, if you want the details of what's inside, we have no idea. But in general, everything's inside a black hole. Anything that falls in is in there. Now what happens to it once it's in there, we don't know yet.
Don't know. And I personally do not wish to find out.
I think
Pay a high price for curiosity. A couple of people also asked about why the Earth doesn't cool off on the side that's dark at night. And I thought that was a really good question, a really interesting question. Think about the Earth when the sun's shining on half of it. The land gets warm, the oceans get warm, the atmosphere, the air gets warm. That doesn't cool off instantly as the minute the sun goes down. It gets a little cooler, but our atmosphere blankets a lot of heat. If we didn't have an atmosphere and if we didn't have an ocean, then I think things would change much more quickly when the sun goes down. And many planets don't have, like Mercury doesn't have any atmosphere, and it's brutally hot on the sun's side and cooler on the side that isn't facing the sun. So we have a lot to thank our atmosphere for, and that's one of the things that kind of smooths out the heat of the sunlight for us. I think we covered a lot of these. Are there questions that you've thought up while we've been talking? Things you were afraid to ask earlier, but now you want to?
Anybody have any questions? If you don't want to say it out loud, you can point to it on your screen and I'll say it for you. Okay, there's been some other questions about the axis. So the axis is tilted 20 degrees. Okay. So one of the questions was, how did they find this out? Now we have GPS, so that that would help us figure that out. But way back in the day, how did they figure this out before computers and GPS and things like that?
Okay, actually people have known about this for more than 2,000 years. Think about that. Before the time of Christ, people knew this, and they actually knew how things were changing very slowly. Because they paid more attention, maybe, to things that they had to look at than we do. Because we have GPS, and we have the internet. But they had a more beautiful sky than most of us will ever see to look at every night. And I can ask you to imagine something again, and that if you could go further and further north, so put on a really big coat and keep going, like Superman, all the way up here to the Fortress of Solitude and beyond, at some point you'll reach the North Pole of Earth. And if you could do that in the nighttime, which would be pretty easy to actually, at the North Pole, be there for months at a time, look up and see the stars spinning about a point apparently right over your head. So even from other places not on the North Pole, we can see the sky apparently spinning around us. And in fact, for a long, long, long time, people thought the stars were all kind of painted on some big globe that we could see from the inside, and that it was spinning around us. If you pay attention and watch and kind of trace things, you can figure out what point on the sky is spinning around. And that's how we've been able to figure out our orientation in space. And the sun, at different directions through the year, is what helps us figure out that 23.5-degree tilt that the Earth has. Who knows why it has it exactly that?
Are there other planets
A
that
really
have-
big thing whacked into Earth, it might change it. It's just like you could change a top spinning if you bumped it or something. But we're not easy to change at this point, probably.
Are there any other planets that have a tilt like we do?
Yeah, Mars is very much like Earth. It's almost the same tilt. Other planets have, actually Venus is kind of upside down, and Uranus is sideways. So planets have very different axis tilts depending on their particular history, which we can't really know. You good on that?
We just finished talking about seasons last week, before spring break, and we've just started talking about the moon and the phases of the moon. So we're just kind of starting into that. So they're kind of relating like what we've talked about back to previous content.
Right.
So lots of wheels are spinning. I hope.
That's the way it goes.
Okay.
It's always better to ask questions than to know stuff, I think.
Okay. I haven't seen it, but have you seen the movie Interstellar?
Yeah.
Interstellar? Alex has. Okay, I'll let
Okay. Lots of questions about that, and they all want to know, are the facts that are given in Interstellar possible, true? I don't know. I haven't seen it, so I can't speak to it.
So they very famous astrophysicist Kip Thorne worked on it with him. So the image you see of a black hole is actually the best image that's ever been modeled of a black hole ever. It's accurate. It's very good. The time dilation. So in the movie, when they go to the planet that's orbiting the black hole, and it's in a deep gravitational well, and so they say that time moves much slower relative to outside. That's all accurate. I will say that for the people who have seen it, the miscalculation of the thing they didn't think about when they went down, they would have thought about that in real life. That the person who was on it admitting was only there for a couple hours. Yeah.
How many of you guys have seen the movie? Okay. There's like, some love it, some hate it, and a lot of us haven't seen it. So, yeah. Okay, so question up, when you're in space, do you get more fit, like physically fit when you're in space, or do you get less fit? I'm guessing less.
Yeah. In fact, they have to exercise really hard to not end up being really bad when they get back. The problem of not dealing with gravity every day is that it starts to weaken your bones and your muscles. So they do lots and lots of exercise to try to keep that from becoming a big, big problem. But it's like anything else. If you sit all the time, you're not going to be as fit. You're not stressing as many muscles that way. You're not exercising, keeping your bones strong. So I think the biggest problem is bone loss.
Okay. Cassie, nice and loud. Or, you want me to read it? Okay. Okay. So when we first started talking about space, we watched what was that show called? It was something like How how the universe was made. It was a Discovery or History Channel show, fantastic show. But and they got to see like the early solar system and the computer animations of the different asteroids and planets crashing into each other, causing these big, huge explosions. So the question is, how could something much smaller, so like the asteroid that hit the Earth and killed the dinosaurs, so how could that tiny thing cause such a huge explosion? Is that right, Cassie? Okay. Yes.
Okay. So, think about a BB gun or a gun. You have a tiny bullet, and that bullet, when it's fired, can do a lot of damage because it's moving at a high velocity. So it's something small, but it has a lot of energy because it's moving quickly, and it hits something that can cause that energy has to go somewhere.
So anything that falls to Earth is guaranteed to be moving fast when it hits us. So if it's a big thing, it's going to bring a lot of energy with it, and that energy is going to get used and spread around somehow. Noise, carrying up rock, melting things, but for really big things, you mentioned the event that maybe caused such a dramatic change that it was responsible for the dinosaurs dying out. That was many miles wide. That just isn't very likely anymore, but it was a lot more likely in the earliest days of the solar system.
Okay, so this may be our last one because I'm sure you guys have things you need to go do. So I know, like they say, the estimates for the Earth is, hold on, let me think, 6.5 billion years. Is that right? Is that the right number?
4.5.
4.5. Where am I getting 6.5? Okay. Anyway, so the question is, how long did it take for the universe and everything in it to form? Even though, like, we talked about how there's still things forming now and it's expanding and blah blah blah. So, do we have like an idea as to how long has this been in existence?
Well, the universe is a big thing. So I want to be clear that we're talking about the universe and not the solar system, but the universe.
Universe. Yep. The big.
Absolutely everything. Bizarrely enough, we do have an idea of how long it's been in business, and that's something like 13 or 14 billion, with a B, billion years. So about halfway through that time span, our galaxy was forming, and about 4.5 billion years ago, our star formed, and the planets formed along with it. And we know all that from rocks and minerals in the solar system.
For the Earth.
For the Earth, right. So, yeah, we're kind of a youngster in the galaxy, which is pretty much a good thing, but we're not the last stars and planets to be formed either. So that's kind of cool.
Awesome. Well, thank you so much for doing this. I really appreciate it. They have been excited about this for a long time, especially since I wouldn't tell them what we were doing for the longest time. So I will, if they have any other questions, I'll just have them email you.
Yep.
Sound good? Okay.
Yeah, we'll keep that email account open.
Awesome. Yay. Thank you so much for setting that up. They've set up an email. It's, and I'll give you guys the address. So you can email these questions to them, and then we'll respond back to you. So if you didn't get your question answered today, you can feel free to send them in. Okay? Awesome. Well, thank you so much.